Hello, my name is Dr. Naftali Brezniak. I am an orthodontist and an AAO member. I graduated from the University of the Pacific about 40 years ago, and some of you may know my name from the AAO root resorption reading list. Clear aligner therapy is now a well-established treatment modality. Despite this, current clinical practice still relies on a single biomechanical protocol, one aligner per stage, manufactured from a uniform material and worn continuously over several days. The well-recognized gap between digital treatment plans and actual clinical outcomes, particularly in movement requiring root control or bodily movement, is not primarily biological. It reflects a loss of biomechanical control during the aligner stage itself. The problem is not force magnitude. The problem is loss of coronal mechanical restraint. When an aligner is inserted, contact between the aligner and the tooth crown establishes a coronal constraint point that bypasses the center of resistance and defines the effective axis of rotation of the tooth. Thermoplastic materials undergo creep, stress relaxation, and thermal sensitivity. As a result, coronal restraint decays over time, the constraint point migrates apically, and the effective axis of rotation shifts within the same treatment stage. The innovation I am presenting is a clinical method, not a new device. Instead of using a single aligner per stage, this method employs multiple aligners that are geometrically identical but differ in mechanical stiffness worn according to the predefined temporal schedule within the same treatment stage. During daytime hours, lower stiffness aligners allow biologically mediated tooth movement. During nighttime hours, a higher stiffness aligner is worn not to increase force, but to renew the preserved coronal mechanical restraint. In this way, sufficient cumulative control is maintained, allowing the effective axis of rotation to remain relatively stable throughout the treatment stage. This method has been formulated as a non-provisional patent application and represents a clinically deployable minimum viable product that can be implemented immediately within existing clear aligner systems. A novel publication describes the biomechanical rationale underlying this approach was submitted lately. The innovation itself is the clinical protocol that bridges digital planning and real-world clinical outcomes. Thank you very much.